Welcome everyone. Today we are going to continue with our lecture series on solution of civil services mathematics optional, which took place on 29 September 2019. Yesterday we have already uploaded a video on differential equation, and today this is the second video that we are going to put up, and the video lecture on vector calculus. So we are going to provide you the detailed solution of this topic. Before I start taking questions, I would like to make an important point here that this year the question was asked for 60 marks. So last year it was 72 marks in 2018, and before that it was 53 marks. So this is the first question, and this appeared in the compulsory part, and this is question number 5e. We have to find the directional derivative of the function x y square plus y z square plus z x square along the tangent to the curve x is equal to t, y is equal to t square, and z is equal to t cube at point 1, 1, 1. And this was asked for 10 marks. Alright, so we have to find the directional derivative. So we have to find the grad. We will take this function as f. So we can write this as 1. Now we have to find the gradient, that is grad of f. You can write this as, and this is a scalar function, and we know the gradient of a scalar function is a vector quantity. So we can write this as I by dou x plus j dou y plus k into f. So we can write this as I dou f by dou x plus j dou f by dou y plus k dou f by dou z. Now we will take the partial derivative dou f by dou x. I can write this as, here it is going to be y square plus 2 of x z plus j, and here we are going to get 2xy plus y, so this is a z square, plus k times, k is the unit vector. So here it is z, so this is 2yz plus x square. So we have to find the directional derivative along the tangent to this curve. So we have to find out what is our grad at this point. So grad of f at 1, 1, 1, we will put the value of x, y and z is equal to 1 respectively. So this is our 1 plus 2 is 3, so this is 3i. Similarly all the values are 1, so this gets repeated, 3i plus 3j plus 3k. Now we are given a general point, that is x, y and z. So we have to find the tangent. So if we take a point as to this, that is x, y of z, so we can write it as t square and t cube. Alright, we can also give a vector notation, that is r can be written as ti plus t square j plus t cube k. So we have to find its slope to that tangent. So this becomes di by dt. So this becomes I plus 2tj plus 3t square k. And we have to find at this point, that is 1, 1, 1. This is in Cartesian coordinate and this is in parametric form. So we already know its value. This is 1, 1, 1. So this satisfies for all. So we get our t as 1. So we can put here at 1 is equal to, this is going to be I plus 2j plus 3 of k. Now this is along the tangent to this curve at this point. So that means we have to take the normal vector, and that will be to this point, and that is the unit vector over here. So you can find it as I plus 2j plus 3k divided by under root of coefficient of this one is 1 square plus 2 square plus 3 square. So we get this as I plus 2j plus 3k divided by, this is 9 plus 10, 9 plus 1 10 and 10 plus 4 is 14, so under root 14. So we have got our unit vector and we have got the grad at this particular point. We have to find the directional derivative that is in the direction to the tangent to this point, that is the unit vector. So we are going to write our value over here. So this is going to be directional derivative is our grad of f at this point and dot product of the unit vector. So we have got our value. This is our 3i plus 3j plus 3k. Dot product of this is I plus 2j plus 3k divided by under root of 14. Alright, so we can find the value, and this amounts to 3 into 1 is 3 plus 6 plus 9 divided by under root of 14. So this is 18 by 14 under root. You can write it as 18 into root 14 divided by 14, and this can be written as, so this becomes 9 by 7, 9 under root 14 divided by 7. So this is our answer. This was just a simple question for 10 marks. Now I am going to take the next question on this series. So this is the question number 6b, and it is asking us to find the circulation of f around the curve C, where f is equal to 2x plus y square I plus 3y minus 4xj, and C is the curve y is equal to x square from 0 0 to 1 1, and curve y square x is equal to x from 1 1 to 0 0. This was asked for 15 marks. So now I am going to solve this question. Before that, I must draw the figure, what it is, the curve. So if I draw over here the curve, this is saying that curve is y is equal to x square from 0 0 to 1 1. So if we plot here, this is, say we call this as 0 O, and this is a parabola y is equal to x square, and this is from 0 0 to 1 1. And secondly, it is saying curve, this I will call as curve 1, and this is y is equal to x square. Second, it is saying that curve y square x is from 1 1 to 0 0. So if I plot from here, if I call this point as A, so our curve C1 is from 0 0 to 1 1, and curve C2, that is our y square is equal to x, this is called C2. This is from 1 1 to 0 0. We have to find the circulation. Alright, so first of all, we have to write this f of dr, that can be written as f is given as 2x plus y square I plus 3y minus 4x j, and the dot product of dxi plus dyj. So we can write this as 2x plus y square dx plus 3y minus of 4x d of y. Okay, so here we have to find the circulation. That means, first of all, for C1, that is along OA, we have to see here x runs from 0 to 1. Alright, and we have this curve, C1 curve is y is equal to x square. So I can write this FDR is equal to along C1 and along C2. This will give me my circulation. So I am computing for C1 and then I will compute for C2. So I will call this my integral 1, that is along C1, and that is equal to, we have our limits running from x is equal. So what is our f dot dr? F dot dr we are having here. So we can write this as 2x plus y square. So in place of y I will put x square. So this will become x to the power 4 and this is dx plus 3 of y. What is y? Y is our x square minus of 4 of x and this is dy. So we can write over here our dy is equal to 2x and here dx. Now we will compute this. So this is our x is equal to 0 to 1 and this is 2x plus x to the power 4 plus this is 3 into 2, 6, this is 6 x cube minus of 8 s square d of x. Okay, so we are getting this value, we can integrate it now. So this is our 2 into x square by 2 plus x to the power 5 divided by 5 plus 6 x to the power 4 by 4 minus of 8 x to the power 3 divided by 3. This is our 1, limit is 0 to 1. So we can put the values. So this is our how much? 1 plus 1 by 5 plus this is 6 by 4, that is 3 by 2 minus of 8 by 3. So if we take the LCM, this is our 30. Alright, so this is, we can write this as 30 and that's plus 6. For this we can write 15. 15 3s are 45 minus of, we have 3 into 10. Okay, so this is our 80. So this is our how much? 30 plus 45, 75. 75 minus 80 is minus 5 and plus 6 is 1. So we get this our integral 1 is equal to 1 by 30. So we get our I1 as 1 by 30. Now we'll find the I2. What is I2 asking us? We have to talk about curve 2, that is here from A to O. So for this we have to write the value, that is, we are talking now about C2. It is along what? It is along A to O. And here we can see our y is running from 1 to 0. So I can write 1 to 0 and here the curve is x is equal to y square. Alright, so I can write my things from here on. So I will talk from here. So this is my FDR. So our I2 is along C2 FDR. So this is how much? This is limit is running from 1 to 0 and FDR is how much? 2x. Now we have to talk only in terms of y. So in place of x I can write y square. Alright, plus y square into dx. What is our dx? Dx is 2y dy. So we can write this 2y dy plus what is here? We are having 3y minus 4x. X is again y square and here we can write this as dy. So we have found I1 and there we are finding I2. So this is I2 is equal to y is equal to 1 to 0 and this is 2 plus 3y square, 3 into 2 is 6y cube dy plus 3y minus 4y. We can write this as it is. Now we will integrate. So this becomes y to the power 4 by 4 plus 3 y square by 2 minus of 4 y cube by 3, and here limit is 1 to 0. So this is our 3 by 2. So if you put the value 0, so 0 0 minus 1, so this is minus of 3 by 2. Here also same thing will happen, 3 by 2, 0 0 minus 1 is minus, so this is again minus 3 by 2. But here 0 minus of minus 4 cube is minus, so this becomes what? This becomes our plus, this becomes minus 4 by 3, and here we are having as our 1 cube. So this is becoming minus, minus becomes minus, minus becomes, so this is how much? Minus 3, and this is minus, minus become plus. So we can write this as 3, and this is 4 minus 9, so this is our how much? Minus 5 by 3. Alright, so we have got our I1 and I2. So I2 is minus 5 by 3. Now we will find our I, that is I1 plus I2. So I1 is 1 by 30. This is minus of 5 by 3. So this becomes our 30. So this is 1 and this is 3 into 10, so 50. So we are getting our answer minus 49 by 30. So this is the answer for circulation. So this is how we find the circulation, and it is important that we also verify our answer in the examination. So this is our answer to this question, and we can use the Green's theorem to verify our answer in the examination. Sometimes they may even ask to verify through Green's theorem. So we can write this as dx of dy, and here we are having m dx plus m dy. We can here it is 2x plus y square dx plus of 3y minus of 4x square 4x dy. So this is m, this is n. So we can write the RHS is equal to, this is what is the derivative of dou n by dou x, this is n. So it is how much? Minus of 4 and minus of dou n by dou y. So this is again minus of 2. So this is our dx dy. Alright. And limit we have to put, we are seeing here our limit is 0 to 1 for x is equal to, for x. And what is the limit over here? This is y is equal to, see it is running from x square and it is ending at x. Y is equal to x square and it is ending at y is equal to under root x. So if we will integrate this, this becomes minus of 2 and this is x is equal to 0, 1, and we can write this 2 plus 2y dy dx, and the integration of y is equal to x square into to the power x root x. So we can find this. So through this, if we will verify, we will get the answer as minus 49 by 30. So if you verify this, you will get this answer. So this will help you to verify your answer, because many times on easy questions people make silly mistake in calculating. So you can verify your answer through this. They are just after circulation, we have to end till here only, but if you want to verify, you can verify through this. Now I am going to take the next question. So this is the question 7b. You have to find the radius of curvature and radius of torsion of helix. X is equal to a cos u, y is equal to a sin u, and z is equal to au tan alpha. And this was asked for 15 marks. So in this kind of question, we can write the formula as well. Okay, so first of all, I am going to write the formula for curvature. So this is our dr by du into d square r by, and here you have to write dr by du whole mod to the power 3. This is the direct formula, and you have to write the formula for torsion, that is equal to dr by du d square r by du square dq r by du whole cube, and this is by dr by du into d square r by du square, and this is the whole square of this formula. So this is the standard formula for curvature and torsion, but here we are asked radius of curvature. So we know that the radius of curvature is reciprocal of curvature. So rho is 1 by k. Similarly, if we have to find the radius of torsion, that is equal to reciprocal of the torsion. So we have to use this formula. Now we have to make some computation, that is we are given r, so we can write our r as a cos u, a sin u, and z is au tan alpha. Now I will find my dr by du. This is my minus of a sin u, this is a cos u, and this is a tan alpha. Secondly, we have to find this d square r by du square, and this is a minus a cos u minus of a sin u, and this is a 0. Similarly, we have to find the dqr by d u cube. This is our a sin u, and this is our minus of a cos u, and this is our again 0. So first of all, I am going to find dr by du into d square r by du square, and then I will take the mod, and thirdly I will take this one formula and this formula, and then we can put this value in this equation and we will get our answer. So first of all, I am writing here my dr into du into d square u by dr square r by du square. So we have to find the cross product of this one and this one, this vector. So I can write this as I, j and k, and I can write my values from here. First it is minus of a sin u, a cos u, a tan alpha, and this is minus of a cos u minus of a sin u and 0. So here we can find our dr by du into d square r by du square. So if we take this cross product, so first we are taking for this I. So a cos u into 0 is 0, and this is minus minus become plus. So we get our a sin u tan alpha, then minus of j. Now for this part we have to take from there, this is 0 and this minus minus become again plus. So minus minus is going to become a plus. So this is our a cos u tan alpha plus k times for this one. This is our a square sin square u plus minus minus become plus. So this is our a square cos square u. So we have got our dr by du cross d square r by du square. We have to take the mod of this also. I will take the mod here itself, dr by du into d square r by du square the mod of this one is going to be under root of, what is this component? This is a square sine square tan square alpha plus a square cos square u tan square alpha, and this is our sine square u plus cos square u is 1, so this is our a square itself. So we will take this out as a to the power 4. So this becomes, we can take here, you can see here this is common, so we can write this as a square tan square alpha plus a to the power 4. So this will give us a plus of, here there are a square, so for this one a, so I have missed the a square here and here because a into a was missed here, similarly for this one also. So all of this become a to the power 4, a to the power 4 and a to the power 4. So this becomes 9a square 1 plus tan square alpha. So this is a square sec alpha. Now I will find my this dr, this formula, so I will write this as dr by du d square by r du square dq r by du cube. So this we have to find this vector. So this is our again minus of a sin u, a cos u, a tan alpha, and here it is minus of a cos u, minus of a sin u and 0. Here it is a sin u minus of a cos u and this is 0. So we are having this as 0. So we can just take this component and this is our a tan alpha. So this is minus become plus. So this is our a square cos square u, minus into minus become plus. So this is our a square sin square u. So this becomes our a cube tan alpha. Alright, and the final thing that we want is our dr by du mod. So dr by du mod can be written as, this is a squared sin squared u, a squared sin square u plus a square cos square u, okay, plus a square tan square alpha. So this is our a square itself. So this is a square 1 plus tan square alpha. So this is our a sec alpha. So we have got all our values. Now what we have to do, we have to just put those values and we will get our answer. So first of all I will start with my radius of curvature. So this will be the reciprocal of curvature. So radius of curvature is reciprocal of this one. So what is dr by du? Dr by du is a sec alpha. So we have to take the cube. So a cube x cube alpha divided by, what is dr by du into this product? This is a square sec alpha. So this becomes our a sec square alpha. So we have got our radius of curvature as a sec square alpha. Now I am going to find the radius of torsion. This is the reciprocal of torsion itself. So I will just revert this. What is dr by du into d square? I can take this value from here and we have to actually square this. So when I square it, it becomes a to the power 4 sec square alpha divided by this term. So this term is how much? A cube tan alpha. So this is our a, and we can write this as, this we can write sin alpha into cos alpha, this we can write as cos square alpha. So we get it as a sin alpha cos alpha can divide and multiply by 2, so we get either 2a sine of 2 alpha. So this is our radius of torsion, and this is our radius of curvature. So we have got our answer. Now I'm going to take the next question. Okay. So the question number 8c, that says state Gauss divergence theorem and verify this theorem for f is equal to 4xi minus of 2y square j plus z square k taken over the region bounded by x square plus y square is equal to 4, z is equal to 0 and z is equal to 3. This question has been repeated many times in civil services examination, but here we have to first of all state Gauss divergence theorem. So we will write Gauss divergence theorem that states that if f is a continuously differentiable vector point function and S is a closed surface enclosing a region V, then triple integration over volume and this is the divergence of this function is equal to surface integral of f and ds, and n is a unit normal vector that is drawn outward. So this is the statement. First of all, we have to start with this statement and then we have to proceed to solve this question. Now it is important that we first write the given things on one side and then we will try to solve this question. So we will start with our LHS. This is triple integration of divergence of f df equal to this was the theorem. So we are going to start with left hand side. Our divergence of f is into plus and there is a dot product here. So this is our 4xi minus 2y square j plus z square k. So we will differentiate I component with dou by dou x, y component dou by dou y and z component dou by dou z. And this is a scalar quantity. So this is our how much? This becomes 4, this becomes minus of 4y and this becomes plus of 2. There. So we have got our divergence. So now we can write this as triple integration of 4 minus 4 by y plus 2z, and here in place of dv we can write dx, dy and dz. All we have to do, take out the limits. So our limit z runs from 0 to 3, and if we take from this equation you can write y is equal to 4 minus of plus minus. So y will run from minus of 4 square to 4 minus x square under root, and x is running from, if you put this y is equal to 0, x square is equal to 4, so x runs from minus 2 to 2. Now we will take the multiple integral of this. So we are starting with first of all z. So this is our, so we can write this as 4 minus 4y into z plus 2z square by 2. We can put the value of z. Z is equal to 0 to 3. So if we write on that side, what we will get? We will get x is equal to minus of 2 to 2, y is equal to minus of 4 under root this, and under root 4x minus 1. Now this is how much? 3. So we can write this as 12, and again this is 12. So 12 minus 12y plus 2 get cancelled. So now 3 square becomes 9. So we can write this as, okay, so 12 plus 9 is our 21. So we can write it over here 21. Now we are seeing here we have to integrate with respect to dy y and then x. You can see here this is an odd function. Y is an odd function, so this can be cancelled out. Okay. So we are left with only this one. Now we are left with 21 dx dy. Okay. So if we are going to, because this is an even function, so we will take 2 outside and 21 outside, and this becomes our how much? 0 to 4 minus x square under root dx dy. Similarly, now we have got our this as 42 integral how much? 4 minus x square dx. This is what? This is a even function. So we can write is a x is equal to 0 to 2 into 2. So this becomes 84. Now if we put the value here, x is equal to 2 sine theta. Okay, so this becomes how much? X is equal to 0. So 0 sine 0 is 0, so that means theta is equal to 0. Now if you put x is equal to 2 here, so 2 get cancelled. So what we got? Sine theta is equal to 1, so theta is equal to pi by 2, and here under root 4 minus of 4 sine squared theta, and we will take its derivative. This is 2 cos theta d theta. Alright, so this will be 84, and this is how much? 0 to pi by 2 is our theta. So this is 2 can come outside, 2 into 2 becomes 4. So this becomes 1 minus sine squared theta, that is cos theta into cos theta, this becomes cos squared theta. So we can write this as 84 into 2, 0 to pi by 2, 1 plus cos of 2 theta d theta. This can be written as 84 into 2, and this is pi by 2. Integration of sine 2x is sine 2x, and we can write this sine 2 theta by 2 pi by 2. This is sine pi, this is 0 and minus 0. So this is 0. So we get our answer as 54 pi. But our work is not completed because we have to verify this. We have just verified for the LHS. Now we have to also show that our RHS, that is over the surface area, this is going to be our value. So we are going to start with the right hand side and prove that the integral value is 84 pi. So over here, you have to start from here. So we have 3 surfaces. If I draw and if I take those axes, let's say this is my z, this is my x, this is my y. So this is my strip number 1, surface number 1. And here my z is equal to 0, and here I take S2, here z is equal to 3, and a other surface called S3. This is s square plus y square is equal to 4. So we have to calculate the surfaces over 3 surfaces. So we will start with this one, RHS, as S1, then over S2, and finally over S3. Okay, so we start with S1. On S1 we are seeing z is equal to 0, and our ds is dx by dy. It's quite apparent, and this is the negative direction. The normal vector is minus of k. So now we can find f dot the normal vector. So f dot normal vector is how much? We are having the f here, we can write it here, and only k component is there, so we can take this as minus of z square. Okay, and your value of z is given, that is 0, so this becomes 0. So on this S1 strip, our surface value, that is S1 f and ds, this becomes 0. Now I am going to calculate for S2. S2 is our how much? Z is equal to 3, okay, and dx is equal to ds by dy, and our normal, that is k. So this is in the upward direction over here. So now I have to compute dot n. So here the same thing will happen, because we have the k over here. So this becomes how much? This becomes z square, and here z square, z value is 3, so we can write it as 9. So over S2, our, this is our how much? This is our S2, and here it is 9, so 9 of ds in this. So we can write this as 9 times this surface. So this is 9 into how much? We have this area, we have to find the area of this, that is pi r square. So pi r is our 2, so this is our 36 pi. So we have got our surface over S2, that is 36 pi. Now last one we have to find through S3. So here we are having a function, that is S3, terms of it is given as x square plus y square minus 4 is equal to 0. So that is normal to that. So we have to find over here normal vector. So this is the grad of this. So this becomes 2xi plus 2yj divided by under root of this one. This is 4x square plus 4y square. So if I take the 2 outside, this will get cancelled, and I am left with only x square plus y square. So my x square plus y square is 4. So its under root is 2. So I am going to write it as 2. Now I will write my f dot n. So our only we have to talk in terms of I and j. So first I is 4x into x is 4x square, divided by 2 is 2. So this becomes 2x square. Alright. The second is minus of 2y square. So this becomes minus 2 get cancelled. So this becomes how much? Y square into 3. This is become cube. So we have got this. So finally we have to compute the over this surface. So if we put here on the polar form, x is equal to 2 cos theta and y is equal to 2 sin theta. Okay, so we can write this as, and theta runs from 0 to 2 pi, and over here we are having the height, that is 0 to 3. So over here, so this becomes how much? 2. In place of x I will put 2 cos theta, okay, whole square, minus of 2 sin theta whole cube. Now you have to find the r, the theta dz. So our radius is 2, So in place of r I will write 2 dr and dz. In place of dr r I have written as 2 and this is d theta, that is r d theta. So r is our 2, so that is how we have written. Okay, if we are going to solve this further, this will amounts to theta is 0 to 2 pi and this is 2 into 2, that is 4 into 2 is 8, so we get 8 cos square theta minus of this is 8 sin cube theta into 2 d theta, and in place of this z is an independent, so this is multiplied by 3. So what we get is our how much 6. So we get 48 0 to 2 pi cos square theta d theta minus of this is how much again 8. This is 48 0 to 2 pi sin cube theta d theta. Alright, so we know this value on the sine function over 0 to 2 pi is sine cube over 0 to 2 pi is nullified, and we will write this on the top. So what we get here 48 0 to 2 pi cos square theta d theta. So we can write this as 48, if I just write it as 24 times of 0 to 2 pi, and this become 1 plus cos 2 theta d theta. So this become 2 pi 24 into 2 pi, and integration of sine 2 by 2 over 2 pi to 0 to 2 pi is 0. So we get our answer is 48 pi for this S3. So our whole surfaces is S1 plus S2 plus S3, and that is equal to 36 pi for S2, and S3 we have got 48 pi. So this is equal to 84 pi, and this is the claim that we made through the right hand side, that from the volume integration for the divergence over here. So hence we have verified this question, and now I am going to take the last question for this session. So this is a question that is asking us to evaluate by Stokes theorem integral over c e to the power x dx plus 2y dy minus dz, where c is a curve x square plus y square is equal to 4 and z is equal to not 2, it is actually 2. Okay, this is a rectification, let me check. Yes, this is z is equal to 2. So this is asked for 5 marks. So we are to write a Stokes theorem. This is a alright. Now we have to use this formula. So if I start with RHS and if I take the curl of f, this is I j, okay, this is dou by dou x, this is dou by dou y, this is dou by dou z, this is our ex, this is our 2y, and this is our minus 1. So if we take the curve, so I, this dou y by minus 1 is 0, dou z y is also 0. So we will take for this one, this is 0, this is also 0 because with respect to z. And finally this is 0 because y and x, this is y and x. So we got our answer is 0. Since we have got the curl as RHS and since this is asked for 5 marks, we can write this and we can say that FTR is equal to 0. If you want to verify, you can just put over here on RHS x is equal to 2 cos theta, y is equal to 2 sin theta, and this will become a circle. So this is 0 to 2 pi e to the power how much 2 cos theta, dx is 2 sin theta minus of d theta plus 2 into 2 sin theta, and dy is 2 cos theta d theta, and dz is obviously 0. So we will see over here. Okay, so if we just put a value cos theta is equal to t, so we will get cos 0 is how much 1. Cos 2 pi is how much? 1. So whatever is the integration from here onwards, its value is 0 because limits are same. So we can verify this. This was a question which is very simple, but still we can check and cross verify. So with this we have done the vector analysis of 2019 civil services examination, and we will be taking up other topics also in times to come. So please like, share and subscribe. If you feel that there are some rectification or some you have doubt, you can ask and you can interact with us. Thank you once more for watching.